Okay, so first I captured the data in Excel. I made the necessary assumptions about the roughness, the dynamic viscosity. Um, I used wrong pressures because I assigned the value of 0 for pressure 1 and pressure 2, while it must be atmospheric pressure, but the results do not change since they are the same pressure, and when they subtract they cancel out. I obtained the friction losses for the elbow, inlet, and outlet from the presentations. I calculated the velocity at the interior of the pipe based on the flux and the area of the pipe. With that velocity, I obtained the Reynolds number and the loss coefficient of the pipe for each case of flux. And then I calculated the theoretical required head of the pump to obtain a flux. And then I plotted the flux versus the required head of the pump to obtain that flux, and the actual head of the pump gives to us. Then I obtained the intersection between the two curves. So where they meet is the theoretical, is where the theoretical and the actual head of the pump are the same, and thus it is the flux we are going to obtain. I calculated the power consumption by multiplying the mass flux with the velocity squared divided by 2. That would be the power consumption if the pump was 100% efficient. So we would need to divide that power consumption by the actual efficiency, which I forgot to do in the Excel. And that's all.